remember that substances can either act as an acid or a base. However, there are a few substances that can act as both. These are called amphoteric substances. They act as an acid or a base. The most common example of an amphoteric substance is H2O. H2O, only 1 in a billion particles of H2O will dissociate into H plus or OH minus. That means in this whole cup of water, if we pretended that it was pure water, there are only a few, just like a handful of particles of H plus ions and OH minus ions. Now, to further understand amphoteric substances, we're going to look at a few example problems. In these two reactions, we are asked to identify the substance that acts amphoterically. So, when looking at this first, you might notice the H2O and think, oh, H2O is amphoteric. That must be our answer. However, water or H2O is not amphoteric in all cases. This means that we have to look at both reactions and see which substance acts as an acid and a base in both reactions. So, let's start with our first reaction. We have H2O plus HCO3 minus is in dynamic equilibrium with OH minus plus H2CO3. So first let's look over here. We can view H2O as HOH. This makes it easier to think about in your head. So what we see in this reaction is that HOH donates a hydrogen to become OH minus, and that donated hydrogen goes to HCO3 minus and becomes H2CO3. So we can say because H2O donates a hydrogen, it acts as a Bronsted-Lowry acid. HCO3 accepts a hydrogen, so we can say that it is a Bronsted-Lowry base. Now let's look at our second reaction and see if we can do the same thing. So here we have HCO3 minus plus NH3 is in dynamic equilibrium with CO3 2 minus plus NH4. So what we can see is that HCO3 minus loses its hydrogen and becomes CO3 2 minus. NH3 gains a hydrogen and becomes NH4. Oh, there should be a NH4 plus. Alright, so HCO3, it donates a hydrogen. So because it is a hydrogen donor, we can say that it is a Bronsted-Lowry acid. NH3, on the other hand, look, it accepts a hydrogen. This makes it a Bronsted-Lowry base. So now that we labeled our acids and bases, let's try and find the substance that's amphoteric. Well, in this example, we can see that HCO3 is a base because it accepts a hydrogen. It becomes this. In their second reaction, we see that HCO3 donates a hydrogen and becomes this. So we can say, because HCO3 is a base here and an acid here, it acts as both and is our amphoteric substance.